Alright, hello everyone. Welcome to our first lesson today on Intro to Numbers. Alright, so as our first lesson of Math 9, this is more of like a review of all the basic math we've done from kindergarten to grade 8. Alright, so hopefully most of it is review, but if you learn something new, that's fantastic as well. Alright, so before we review some of the things that we learned earlier, like decimals and all that, let's talk about some categories of numbers first. Right, so we call those number sets. Right, so those are a bunch of numbers that have similar properties. Right, so for example, one of the more commonly used ones is called natural numbers, and we write this n-looking shape right here. Well, I guess it is an n with just a little dash across there. Right, so natural numbers, by definition, they are what we call counting numbers. Right, so they are the numbers that we count with. So for example, if I were to say, oh, how many, I don't know, what do I have back there? I have a bunch of like Zelda Pokemon figurines. So how many of those figurines do I have back there? Got 1, 2, 3, 4, right? We start counting from 1, and then we go up by a whole number each time. We don't really say I have 2.1, 7.8, that kind of stuff. We always stick to numbers with no decimals. Right? So unless you are a computer, right, we also count from 1, not 0. So no decimals or zeros. Right? Or I guess just 0. Right? So we do not have any of those, which means that our numbers are literally just 1, 2, 3, 4, so on and so forth. Right? So this is literally the numbers we use to start counting things. Next, we have whole numbers. Right, so we denote this with a W, right? And then what's whole numbers? It includes all the natural numbers. Right, so all natural numbers. Right, but it also includes 0 as well. Right, so think of it as all the positive numbers that have no decimals. Right, so we start at 0, and then 1, 2, 3, 4, so on and so forth. Right, so in both cases, they go to infinity, or more specifically, positive infinity. Next is integers. Of course, like any natural or like any person, we use Z to denote integers for some reason. Right? And integers is just all the whole numbers, including negatives. Right? So integers is what we think of when we think of numbers. Right? Starting at 0, we have again all the positive numbers, right? But also we have all the negative numbers. Right? So very importantly, it is the non-decimals. Right? So things like negative 1,755, you got, I don't know, 10,056. Right? So all of those numbers with no decimals are integers, positive and negative. Rational numbers. Of course, instead of using R, we use Q, because why wouldn't you? Right, so rational numbers are all the fractions. Right, so all fractions, which means that because they are fractions, it means that we also have decimals that end or repeat. Right, so that's an important keyword here. Decimals are rational only if they end or repeat themselves. Right, and or repeat. Right, so for example, any fraction will do. Let's say like negative 2 over 3. Right, that's a fraction. Negatives is still a fraction. You got things like 0.75. Right, a nice little decimal number that actually ends. Right, it ends at 5. We will learn a bit more later on about how to convert between decimals and fractions, but decimals and fractions are essentially the same thing. Next is repeated decimals, something like 2.4, right? Or more specifically, 2.4 repeating. So this line above the number, right, just tells us that this is 2.44444 and so on and so forth. Right? This 4 repeats forever. So we write a little line on top to denote that. And of course, this is rational because a repeated decimal can also be turned into a fraction. Okay, how about irrational numbers? This is where we save the I for. Irrational numbers are decimals that don't end. So they're pretty much like the everything else. So decimals that don't end. Right, so for example, pi. Right, pi is what? 3.14152.9, blah 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 blah. Right, that goes on forever. And something like square root of 2. Right, if we plug that into a calculator, right, square root of 2 is like 1.41. Yeah, so this is what you got in the calculator. Notice how, yes, it ends, like, it quote unquote ends on the calculator. That's because the calculator ran out of room. Right, just like that. But for another example, let's take the fraction 1 over 7. Or, no, sorry, not 1 over 7. Oh, sorry, it is 1 over 7. Right, so, as you can see on the calculator here, it's got 142, 8571, or 142, and then 857. And then once again, 142. So you notice how, even though it's a longer string of numbers, it started repeating again at the 142 part. Right, so that indeed is, or 1 over 7 is rational, whereas square root of 2, because the decimals kept going without repeating, it is irrational. Okay, last one, real numbers. So real numbers pretty much encompasses all the numbers that we will encounter in real life. Alright, so it's all the rationals and irrational numbers. Alright, so pretty much every single number you see is a, oh, sorry, shouldn't be R here, should be Q. Even I'm getting confused. Right, Q and I. Alright, so all the rational and all the irrational numbers. Alright, so that's all of the above. Right, pi is a real number. Negative pi, real number. 56, real number. Square root of, I don't know, 17, real number, right? So all the numbers are real numbers. And I think either grade 11 or grade 12, you'll learn about imaginary numbers, but that's a later problem. So as you can see, we can put it into this little, not really a Venn diagram, but a diagram of some sort. Right? You can see that all natural numbers are whole numbers. So say example 5, right? That 5 is a natural number, but it's also a whole number. Right? 0 is a whole number, but not a natural number. Right? So each of those categories include the previous one. Right? So integers could be things like -4 and I don't know, 272. Right? So notice how the number 0 and a natural number of 5, all of this right here is included in our integers category. Right? So pretty much all natural numbers are integers, but not all integers are natural numbers. Of course, as rationals, right? Something like 4 over 5. Right? And of course, integers are rational as well, right? Because 5 is just 5 over 1. Right? That's what 5 is as a fraction. So everything's included as a natural number. Irrational, once again, things like pi, right? Very different. But all of this, right? All the rationals and irrationals, all of this is considered a real number. Right? So now, as a little for funsies exercise, I want y'all to pause the video here and then check off all of those numbers. Right? Oh, my camera's in the way here. Ah, there we go. Right, so I got a bunch of different numbers here. I want you to check whether or not they are natural, whole numbers, and so on and so forth. Right, so pause the video here to give it a shot. Okay, I know you definitely paused the video to try it out yourself. So, we know for a fact that all of them are real numbers. Like I said, all the numbers are real numbers essentially, or at least the ones that we see. So let's look at 8 here. We know 8 is a natural number, right? It is a whole number that is above 0. And like I said, it's a whole number because it has no decimals. Right? Or it technically has a decimal, it's 8.0, right? That's its decimal. But because it's 0.0, there's no decimal. Okay, integer, yes, it is a whole number, so it is also integer. Is it rational? Yes. Right? As you can see here, right? Because we know it's a rational, it has to be integer, it has to be a whole number, it has to be a natural number. Irrational, right? Not an irrational. 8 is just 8 by itself. It's not a repeated decimal. Okay, how about negative 100? Natural, it's now natural. We do not count with negative 100, right? Remember, it's 1 and up. Whole number, also not a whole number. Whole number is 0 and up. Integer, definitely integer. It's a negative whole number. Rational, definitely irrational. It has a decimal that ends, or it's a fraction, right? Negative 100 is just negative 100 over 1. Same thing. Irrational, not irrational. 2 over 3. Natural, not natural. Whole number, not whole. Integer, not integer. Right? Because all those require you to be just a number by itself. Rational, of course, it's a fraction. Irrational, nope. 0. Natural, indeed not a natural, right? By definition, it is a whole number. Because again, we do not count with 0. Integer, it's integer. Rational, of course it is. Not irrational. Alright, pi makes our life very easy. Like I said earlier, pi is irrational, which means that everything else is a no without even checking. Right? A number, from previous page, right? A number can either be just rational or just irrational. We don't have a number that's both rational and irrational. Okay, how about negative decimal? The first 3 automatically is a no because it has a decimal. Rational? Yep, it's a rational because it has a decimal that ends. Irrational? Nope, because it ends. Okay, how about this one? Once again, we have decimals, so the first 3 is automatically a no. Because right here, this decimal repeats itself. Oh, whoops, I'm blocking the number again. Alright, because this 312 repeats itself. Alright, so it's going to be 4.312312312312. Right? It is still rational because the decimal repeats. Okay. Oof. Alright, let's get going. So now, speaking of decimals, let's work a little bit more with decimals. Of course, as we know, decimal is this little dot right there. Alright, so this is a center point of a number that splits the whole number in its parts. Alright, so this place right here is the ones place. Right, again, hopefully this is mostly review. But if you need to jog your memory, no worries. That's what we're here for. Here's a tens place. Okay. We got hundreds, thousands, ten thousands, hundred thousands. Alright. And then the decimals, it's pretty much the same names, except we just added th at the end. So that's a tenth, hundredth, thousandth, 10,000th. I remember struggling with those a lot when I was learning English. And of course, oh, just one more, just kidding. 100,000ths. And lastly, of course, is 1,000,000. Or sorry, not 1,000,000. What am I talking about? Millions. So I just went on autopilot there. 1,000,000 is a million. There we go, millionth. So place values. Right, and of course, we can put the decimals on number line as well. Right, so remember, decimals kind of split the number into smaller parts. So starting with 2.5 here, right, it's positive 2.5. So we go to 2 right here. 2.5, right? Because it's 0.5, it means that we're in the middle of 2. Or more specifically, we're in the middle of 2 and 3. Right, so 2.5 is somewhere right here. And because it's 2 point something, it's closer, or it will start at 2, and then it will go a little bit, but not quite reach 3. Right, so 2.5 is here. Of course, the same in the reverse. Negative 2.5 will go somewhere here. I have to be careful. This right here, that's negative 1.5. Right, so on the number line, the right side is the positive side. The left is negative. So negative 2.5 is in between negative 2 and negative 3. Right, and now how about fractions? Right, 4 over 5. This means that we have 5 parts of something. Right, 1, 2, 3, 4, 5 parts. And we fill out 4 of those parts. So as you can see here, it's not quite 1 yet. Right, it's just below 1. Right, if it's 1, all the boxes will be filled out. So 4.5 is somewhere right here. Yeah, notice how it's closer to the 1 than the middle, right? Because we know the middle is 0.5. All right, and the 4 over 5, as you can see here, if we have 5 parts, the middle will be somewhere here. Right? But we have a little bit over here that's over the middle point. How about 6 and 4 over 5? All right, so we look at a big number, 6. All right, we know for sure it's going to be somewhere here. Right, between the 6 and the 7. And because we have a fraction here telling us it's 4 out of 5, with this mixed number, this will go somewhere right here. Right, so it's a bit after 6, but more specifically 4/5 of 6. And lastly, negative 7 point something. We know for sure it's going to be somewhere in this little category. Right? It's going to be more negative than a negative 7. Right? And just like any regular number, right, 0.1 goes up to 0.9 before going to the next number. So 0.2 is some relatively at the beginning of the number. So it's somewhere right here-ish. Alright, so that's how you place decimals on number line. Right, you always look at the big number in front, right? This big number in front of the decimal tells us kind of exactly where to put our decimal numbers. Of course, when there's no big number in the case of a fraction, right, that just means that this is kind of like 0 point that fraction, essentially. Again, that doesn't really make too much sense, but we'll learn more when we convert between fraction decimals. Lastly, a rational number between negative 5 and negative 6. You can see right here, between negative 5 and negative 6, it's this little area here. So you can pick anything. In my case, I can pick, say, negative 5.5, right in the middle. Could be like negative 5.000001. Right, that still counts because it's literally just slightly above 5. Within 3.22, 3.24, it's going to be somewhere around here-ish. And we see that it has to be between the 23 and the 24 in the decimal place. So what we can do is add the thousandths place. If we add a little decimal here, right, this added decimal place makes it so that we are now in between those two numbers. Of course, you can get a little more ambitious. This also counts as in between. As long as there's some decimal places above the 3.23, you're fine. Alright, that's our lesson today. Right? Again, hopefully this page is most like a review. Right? But again, if this is new material to you, right, just make sure to practice. Right? We'll be using a lot of this terminology and decimal throughout our class, and probably for the rest of our life, whether you like it or not. All right, so yeah, that's all. Take care.